On this episode of the podcast, I have with me Ken Farmer. He is the data engineering manager at Alto Pharmacy. We're going to cover a little bit of different topics on this episode. We're going to be talking about what a modern data warehousing solution looks like. How different is it from the solutions of old? We're going to talk about the beauty and simplicity of solutions versus some of the complexity and just some of the what might seem like the chaos of being produced. And how do you actually make sense of that noise? We're going to be talking about a little bit of the movement away from GUI tools towards data engineering as the software engineering discipline. And we're going to cover a lot of ground. Hopefully we can get as much as this as we can with Ken's time. Ken, awesome for you to be on. Thank you.
Glad to be here.
Absolutely. Absolutely. So I introduced you really quick, I guess, just to give us a little bit of context. Can you just give us a high level of what Alto Pharmacy does?
So Alto's a pharmacy that's a late stage startup that's, I think, about 7 years old at this point. And what we do is we deliver prescriptions same day with no charge in all the markets that we're active in. And so what that means is that we can receive a prescription. Our customers don't have to leave their house. We'll courier it right to their homes.
Very cool. Wow. I'm sure that's a good solution for this COVID world. But let's dive in. I know we talked about a lot of different things, and I want to give us the maximum time to cover it. So let's start at the top. I know you got a pretty good background, data engineering. Obviously, your LinkedIn profile will be in the show notes, so we can go take a look at that. But when we're talking about a modern data warehouse solution, maybe let's talk about what does that mean to you and set some context to that.
You bet. I'm seeing that terminology show up quite often these days, with vendors in particular kind of proclaiming that, this is a modern approach. But what I'm really seeing them offering is quite often some of the same techniques that were being used 20 years ago. So it doesn't really seem entirely novel. There's maybe a little bit that's slightly novel, but not that much. From my perspective, what I look at as a modern data warehouse is an environment that supports DevOps practices, agile methodologies. It's keeping raw data available like you would in an ELT solution, but that's been a part whether you're using ETL or ELT. You should be keeping the raw data. So you have that ability to reprocess. You should be considering data quality as a first-class problem because it is one of the toughest challenges that we face. That to me is what I kind of expect when I see what I think of as a modern data warehouse, possibly doing multiple releases a day. They're very low stress. Engineers aren't working weekends to make up for planning challenges. And they're meeting and exceeding the expectations of the user. They have some kind of agile framework assisting them in that fashion. So that's kind of what I imagine as a modern data warehouse. And rather than focus on tools, I'm really more interested in practices and methods. Back to that concept of, kind of like beautiful pipelines and models are in a modern data warehouse. We've learned some tough lessons about how data warehouses can collapse due to complexity. What I expect is somebody can stand up and present how all the pipelines work at a relatively high level in just a couple minutes without having to dive into an enormous amount of details on 10 or 15 or 20 different one-off solutions. Someone could look at the data model and make sense of it. That to me is much more important than the tooling that is being sometimes offered as a solution.
Yeah, and it's interesting, I guess, just hearing you kind of go through the description of what that modern warehouse solution looks like. I guess the one thing that you touched on, data quality, that's not changed. That's been an issue for however long data's been around. I guess, what are your views on just how maybe things are changing, addressing data quality and maybe, how that fits into the modern paradigm?
So data quality has always been one of the very top, maybe 3 to 5 reasons for data warehouse failure, all the way from the very beginning days. It's always been one of the toughest challenges. It typically didn't get as much attention as sexier problems like performance and scalability, but it's actually a harder problem to address. I think today we tend to have better quality data to start with than what we had to start with 20 and 25 years ago. So a lot less data is coming off of kind of opaque data structures on a mainframe based on some system written in 1968. Many more systems are much more modern. So that's kind of helping. If you were to look at a data warehouse from 20 years ago, you might find a greater use of database constraints or declarative data quality definitions than what you're finding in some data warehouse services today, unfortunately. But there's also springing up some additional tooling, SaaS tooling, and products like Great Expectations that can really kind of assist and are helping to kind of promote some thinking around data quality. Finally, I think data quality might have slowed down. I think the changes that it went during some of the big data rush of 10 years ago was kind of a setback because a lot of that was really pushed by more marketing considerations, and there wasn't as much of a concern about around data quality as there was earlier. But I'm seeing that start to reverse now. I'm seeing more and more people recognize that data quality, especially when working with data science and machine learning, is much more important than it was considered, say, 7 years ago.
It's interesting because I do think that when you look at 20 years ago and people were sitting there waiting for a report to come out, that was the biggest issue. Data quality was sometimes second class, as it were. Now, the data is just better coming in a lot of cases. I think you're right. And I think now you have other solutions out there that's helping with speed. I know you'd mentioned before in a conversation, something like Snowflake is making a big impact. It's addressing some of the fundamental constraints of previous days. I mean, how does something like Snowflake, it is an expensive product, but how does something like that come in and help some of the challenges that we used to see?
I think one of the biggest ways it can help is lowering the labor cost to get going. If you were to go back to like 1995, you'd find people spending 9 months before they deploy an MPP server. It might take them 6 months just to get the procurement dollars to spend the, say, $4 million it was going to take to buy an IBM SP2 or something like that, right? And we've known from the very beginning that we needed to have, not box ourselves in on scalability, because you don't really know for sure how much data you might be pulling into your environment in 2 years. So we would spend an enormous amount of time making the case to get the procurement, and then we'd have to assemble a strong team to deploy a complex machine like that. Nowadays, you could just deploy it tomorrow. And because the costing is more on demand, it's a lot easier to get that through procurement. And then it also helped us de-risk it. So now in the event that you've over-procured, you can, right-size your cluster and start to save money. If you decide the whole project was ill thought out, you could even shut the whole project down perhaps and just stop paying. You're not locked into a 3-year, $4 million capital cost. So that's one of the big ones. The other one is, in the case of Snowflake in particular, there's very few levers and knobs to move around. So it takes very little work to set it up, and you don't spend a lot of time building out and customizing your model. You don't spend time thinking about indexes. You don't spend time thinking about partitioning. You certainly don't spend time thinking about managing buffer pools or different speeds of disk or anything like that at all, which is both good and bad. It's great to get started and rolling really quickly, but it also means that when you hit performance problems, there's very few things you can do other than buy more product.
Obviously, those are some challenges and constraints. Previously, you have to apply the manpower to actually solve some of those problems. And it seems like now, some of that is being, abstracted away and it's not necessarily your biggest concern. I guess when it comes to you've got a legacy solution in place or you're looking to go to a more modern data warehouse approach. And I think most people are there. And I think depending on your stage of your organization, whether what your line of business is, there's different life cycles you're probably in. But as you've kind of seen some of that migration, what's the pain points that you, I guess, had to deal with as you were kind of going from that traditional data warehouse to more of the modern solution that you're talking about?
I think one of the pain points is just the higher monthly cost. So it definitely has a lot of benefits, the pricing, but you can easily find yourself spending 4 times the amount of money per month that you were on an on-premise solution. If, whether you're using Snowflake or Redshift or, whatever that technology is, it can come in at a much higher price. Hadoop, for example. So that's one of them. Another one is to really get the full benefit of the capabilities, you're going to have to pick up a lot of new skills. And there's new opportunities in these skills. So DevOps pops up as a methodology to really help ensure that you can take advantage of the dynamic nature of these environments. It really kind of emerged when people realized, hey, we can build our infrastructure with code and we can iterate on it very, very quickly. It doesn't happen if you're building it like you were in the old days and everything's manual at the command line, undocumented. It's just, somebody's shooting from the hip on configuration commands. It all has to be automated to get that benefit. But going through the pain of learning how this works and getting good at it is what helps you get the full value of this more expensive but more dynamic environment.
I guess just to touch on one thing there, and actually I'm kind of curious about the new skills, but just to back up about the cost of what you're seeing in terms of the modern data where obviously that's the biggest constraint. There's a cost associated with that. Obviously, it's a different type of cost versus the upfront. Let's go buy these super expensive servers, pay the licensing. I guess you see a lot of that in infrastructure. Everyone went AWS, then they got the bill, and they were like, "Oh, this is really expensive. We have a data center. How do we build a hybrid infrastructure to kind of take advantage of what we've spent?" Do you potentially see data warehousing needing to maybe, become something like that where it's, a bit of a hybrid on-premise in the cloud just to kind of keep costs down? Obviously, taking advantage of what Snowflake does best. I know a lot of people are doing that, but is that potentially going to be a trend as people see the bills for these cloud, platforms?
I don't run into that very often. And I think one of the reasons why is because that data center comes at a big price tag. And if that's spread across 50 or 100 applications, it makes it more palatable. If it were to be funded just for a data warehouse, it would really add to that cost. So what I find is most of the people I talk to are moving exclusively up into the cloud and only even entertaining thinking about bringing some services back down if they're extraordinarily expensive and at scale. Because there you really start to see it when you're starting to talk about petabytes of data. But having said that, I've still never done that. I've still never pulled it back down to on-prem. So we've entertained thoughts about it, but it's never been so compelling we wanted to bite off that big bullet.
Let's talk about skills because maybe that all ties in, right? So you mentioned needing different skills on the team, right? I'm assuming, let's talk about that because obviously the correlation to that is once you have those new skills, if you want to go backwards, then you need the old skills back. So I guess when you're building the modern data warehouse, whatever the infrastructure looks like, it's in the cloud. How is that skill set different than maybe what you previously had on the team? How do you help with that migration of people going through that type of transition from one platform to another?
I guess what I'd say is there's like maybe perhaps two categories of skills then. We have ETL developers, and maybe there's three different demographics of ETL developers that I see. I see folks who would self-describe as ETL developers, people who would self-describe as a BI developer, and people who would self-describe as a data engineer. And what I'm seeing is that, data engineering is a relatively new term, only about 7 years old. We were doing it from the very beginning. And the term isn't really precise because just like how everybody calls themselves a data scientist these days, almost, the same thing is kind of true with data engineering. So it can be a little ambiguous. But what I'm generally seeing is that BI developers are much more focused on GUI-driven tools and might be doing ETL as just a subset of their total workload, also working on dashboards with some tools like Tableau, for example. ETL developers are oftentimes still using tooling. It might be GUI-driven, it might be command line-driven, but they're very heavily tools-focused. And then data engineers are usually oftentimes solving a harder class of problems and are usually in the custom code space. And it might be a harder problem because it's got very high volumes, very high value, very high complexity, very high variety. Anything in that area starts to really put pressure on off-the-shelf tooling that you can acquire and making more of a case for custom code. So that's one of the things I'm seeing, just the formalization of this way of doing ETL. 20, 25 years ago, if somebody were to say, well, this is a lot of data, I'm going to write some custom applications in order to do the ETL processing on this data because it'll do it more reliably, faster, and cheaper than an off-the-shelf product. The conventional wisdom was that they're wrong, that you can't do it. Well, they never were wrong. It's just that it took a while for, I think, the field to kind of appreciate that a GUI-driven tool is not the answer to all problems. So now I think we just have that formalization, and we're starting to see, these roles kind of diverge a little bit. The other role I see changing more substantially is that of the DBA. It used to be, back in the day, it took a lot of administrative work in order to manage the data. Just doing upgrades on a big data warehouse was a ton of work. And this is one of the areas that I think where, the SaaS data warehouses and cloud data warehouses make our lives so much easier. Whether you're using BigQuery or Snowflake or Redshift or Athena, or even just Postgres on a EC2 instance or an RDS on Amazon. You're not having to patch it. You're not running the backups. You're not having to take the system down for extended periods of time and practice backups and upgrades. That's a huge amount of specialized effort. It's been fantastic to get rid of. I think the harder one that we're picking up is the one I mentioned earlier, and that is, hey, to take full advantage of this environment, you should be releasing very frequently, and you should have fully automated testing. And that means, part of a DevOps culture and picking up the skills to use tools like Terraform and Puppet and Chef and Fabric and Salt and tools of that nature so that you can automate things and not just manually test everything.
I guess when it comes to that, because I think software engineering already deals with that, right? Which is interesting. Everyone else seems to be going that direction, shifting left. So I interview security people and they're introducing, DevOps principles and practices, and it's more in their world on a daily basis. Data engineers are going from GUI operating, tools from years ago to now they need to be software engineers. And the ops side, right? Whether that's continuous integration or whatever technology you need to, I guess, be competitive. This newfound set of skills that are being applied to data engineers is kind of causing that role to evolve more towards a specialized software engineer, I guess, for lack of a better way of describing it. I mean, is that what you're seeing as well? Like you're seeing this new type of engineer being kind of developed right now?
Yeah, I think that's a great way of describing it. That, if you think of a data engineer as a specialized software engineer, that's how we've been interviewing for quite a few years, wherever I've been at. We're really looking for engineers that are committed to the concept of automating tests. We're looking for engineers that feel comfortable with version control, automating deployments. They're comfortable writing the code to go ahead and configure and build their environment on the fly. But what they really love more than anything else is playing with the data. And so they really are deep in how do you model data? What are the common gotchas and traps in moving data around? That's where they're really focused domain-wise. That's, to me, the modern data engineer. And it's a little tricky because every company could have slightly different position descriptions. And there is no ANSI definition for a data engineer, right? So it's just shifting over time. But I think that's, to me, the primary distinction is that a data engineer is using modern engineering methods. ETL developers and business intelligence developers can be just the perfect role and position and set of skills in some organizations. But if the culture of the company is moving towards software engineering best practices, I think it puts a lot of pressure on the ETL developers and BI developers. A lot of the practices in that space aren't keeping up, I don't think.
That's an issue. And I guess this is an interesting, we can address that in a second because I think there is that skill gap forming if you're not keeping up. But in terms of the modern data engineer that's, maybe a specialized subset in software engineering, do you see these type of engineers, obviously they're not really working with the traditional, warehousing methodologies. They didn't come from the data world. They're coming from engineering. Do you see potential gap in terms of their ability to, handle the modeling side? I mean, obviously that's a skill they can pick up, but obviously, they're more focused on different aspects of engineering. Is that an issue or do they come up to speed on that pretty quickly?
I think it is an issue. I think it might be becoming less of an issue. I remember going to the Strata Hadoop conference in 2013, and there was a panel of pretty well-regarded Hadoop experts up talking about the challenges, and they settled on preparing the data as the toughest challenge. Somebody in the audience asked them, are there any practices and tooling to kind of help guide us on this? And they said, no, none existed. And I talked to these folks later, and they were unfamiliar with the term ETL. So, I think the big data movement came from a completely different place than data warehousing, and it had to kind of learn these things on its own. And when I would talk to data engineers in 2013, 2014, you found very few who were familiar with dimensional modeling, for example, or the trade-offs in having just a big wide fact table and a columnar store versus a dimensional model. This was just not in that space. But that's shifting. I think one of the reasons why is maybe the ascendancy of a lot of MPP data warehouse services like Snowflake, like Redshift, where many people are realizing this is much easier to manage than Hadoop. And it's better at 90% of what they were asking Hadoop to do. And so people are, I think, rediscovering some of the modeling and other methods of data warehousing that still apply and work really well today.
It's kind of interesting because when we're asked to help out on that, that's always the little sticky part because it's like, well, you realize that, if somebody's dealing in different environments. They have different backgrounds and experiences. And I guess let's talk about people with those backgrounds, right? So you're in an environment where maybe it's a larger organization or somebody that hasn't moved to this more modern data warehouse infrastructure, and all of a sudden you want to grow your skill set, right? Otherwise, I mean, you potentially can develop a set of legacy skills that aren't as marketable, that aren't as in demand, and obviously, technology doesn't go away. We can look at COBOL. So obviously, it seems like nothing ever really goes away. But how does someone approach it from that perspective? Like, what does somebody do to kind of, get ramped back up, or find a way to kind of upskill themselves in terms of the newer technologies?
Well, I'd say unless they have the good fortune of being able to persuade folks to let them in on a team that's working with some of these other methods and technologies, it's going to take some labor on their side, right? It's going to take weekends and evenings. And that's hard to do and hard to really pick up a lot of material depending on how much somebody feels that they need to learn. But one thing I think that makes it easiest if they really have a passion for it. One of the things that I look for in data engineers is a passion for working with data. Because if they don't have that, after a while, it can seem like a slog if the only thing that attracts them is the tooling, right? But if, let's say, you have a legacy ETL developer and he's been using some GUI-driven tool, and he's kind of seeing the opportunities closing, I would definitely suggest picking up some additional skills. But it may mean, taking a look at maybe a workshop or a class. Certainly going to meetups is a great thing to do. I would also suggest at this point, from a data engineer, we kind of expect data engineers to be very comfortable on the command line, very comfortable using all the typical software engineering tools, whether it's Git or it's writing code in Bash, whatever that whole set is. But in addition, they should have some competence in one of the main languages. The language I typically go to is Python. It's certainly not the only one, but that's my favorite in our space. And I think one of the greatest things that somebody can do is pick some fun projects that they would really enjoy learning. Because if it's a grind, they're going to have a hard time. But if they can pick some fun projects and start doing them and building them, then they can go a very long ways. And they don't even have to. I mean, they can get a small cloud environment on Google, for example, or Amazon to play with, but they don't even have to. On their laptop, they could run Docker containers, they can run Postgres, they can run command line applications, they can write code in Python, they can use Jupyter Notebook. Unlike 25 years ago, this stuff is all really accessible. It's just a matter of putting the time in. And that's, to me, the hardest piece. And that's where it really comes down to, do they have a really engaging roadmap to get them to where they want to be at?
Interesting. No, it's true. Actually, I think a lot of that extra work, the desire to upskill, does come from within. Obviously, you've got to find the time to do it. And if you don't have the passion, we always want to find something else to do with our time versus building a side project that might seem to be a grind. So I think that's fantastic advice.
I think one more thing to add to that is just in the process of starting that education on the side, exploring things, working on their skills, just getting that rolling can be the foot in the door to another team that can pick them up from there. So it can even turn out that the amount of labor that somebody has to put in of their own time to upgrade their skills may be less than the worst case scenario, just simply because committing to it and making progress on it just opens up new doors on its own.
And I guess like the other component to this, the flip opposite issues, obviously, upskilling the legacy skills is very important to stay marketable. So as a hiring manager, there's not a ton of this type of more modern, specialized data engineering software hybrid person, right? It's a lot fewer of them. And the ones that are available, they know their worth. So from your perspective, as you're looking to build out teams and know you need more of those type of modern software engineering oriented data engineering skills, how do you help solve that? Like, what are you looking for if it's not somebody who already is walking in the door with exactly the right skill set?
That's a great question. I think what I have found is quite often the market's been so tight, it's actually put my hiring at risk. Either in an organization I was in, we couldn't quite match, the highest paying offers in our community, or there are just not enough people moving around. People are pretty happy where they're at. It can be a real challenge to staff a team. So what I've typically done is kind of look for a mix of senior, mid-career, and junior people on a team. knowing that the more junior people are easier to find. And it can also help me tap into a more diverse pool of candidates. And then I look for a couple of people who are really, really solid and well-grounded in the domain. And sometimes much of the rest of the team is then more non-traditional candidates. Maybe a web developer who always wanted to play with data, who's super thrilled and passionate about it. And if that individual's sharp and they're passionate, that's somebody who can start adding value in a surprisingly short period of time on the right architecture. Or it could be an ETL developer who doesn't check off all the boxes on data engineering, but is still interested in them. And it's not that they didn't check off the box because they're opposed to it. They just have been working with some different technology, but they're pretty excited at that opportunity. So I would say non-traditional hires are the way of kind of de-risking a project to an extent, as long as you got a core couple of leaders that can kind of guide the team. And they don't all have to be the same person. One of the things that I found sometimes is the best advocate for like DevOps and agile methods on my teams has not been traditional data engineers. It's sometimes been traditional software engineers that wanted to be data engineers. While the advocates for great modeling really came from the ETL developer side, and so it's really that kind of a diverse mix of people can sometimes be the strongest solution, I think.
That's great advice. And, I see it a lot. I see some people that are literally going to wait for that person who's going to come in and make the impact and change because they desperately need that. And then I see others, kind of what you described, they're going to find the best fit, bring somebody in, and they know their architecture, their environment allows for them to kind of help ramp those people up, and they're going to just get on the job experience in the areas they're lacking. I mean, I think you can only have really two philosophies around this, and you just have to determine what pain point you really are looking to address.
And I think, especially if you're also looking to be a DevOps shop, you may find that there's some overlap in the strategies here, because some of the tenets of that set of practices really also help you onboard people. So I think an onboarding and the challenge of onboarding people, how quickly and comfortably they can begin to start to incrementally become more productive, is kind of one of the acid tests for how successful you've been at making a coherent and simple experience in architecture. Or to summarize, I'd say, I think a DevOps-oriented data warehouse has a lot more flexibility in the staffing.
And also, I guess just to touch on that point, I mean, when you're looking at common tooling, there's a lot more. I think this is happening with security, and I think it must be happening with data engineering as more tools are being shared with the actual core software engineering team. It seems that the related discipline is coming more to the forefront in terms of talking about how their solution integrates and impacts at some point, either further down the stream or whatnot. But it seems like it brings people into the conversation more because people are going, oh, okay, we're all using the same tools. Okay, well, how is it that your solution fits in? Whereas before it was like, okay, you're at the end of the line. We're all done. Here's the data. You figure out what you need to do. Let us know if there's a problem.
Right. I find there's a couple types of problems that we get into, especially when there's like a cultural clash. So it may be that the folks working on the data warehouse side aren't fully respected by the software engineers because they're using what appears to the software engineers to be antiquated methods and techniques. They're not doing automated testing. They're not doing automated deployments. They don't have sprints. They just have a kind of a waterfall process, and they're releasing things, once every 3 months. So that with that credibility gap, then especially on smaller organizations, you can find that the data warehouse could also be supporting product. They may have a harder time working with the rest of the engineering team because their methodologies are so different that culturally they're just not fitting in. I think that's one of the kinds of challenges. One of the other ones is working around in larger organizations that really try to solve for all engineering teams, all their tooling and process needs. And data warehousing is slightly different than a lot of transactional application development. There's massive overlaps, but I think it's beneficial to be aware of those differences. We iterate differently. Data warehousing from the very beginning, and I think Bill Inman described it as spiral development in 1992, recognizing that unlike how we build transactional apps where we typically incrementally add and modify, in data warehousing or data science, one of the things that the more likely scenario is we present somebody the answer to a question that then provokes a completely different question. And they may even say, just throw away what you just built. I now see it's not helpful at all. So our iterations aren't just adding and modifying, but they're also throwing things away entirely and starting over again quite often. And because of this, like our agile methods should recognize that we have some differences. We also have users that don't want to wait 2 weeks for us to build some big piece of software. They want a tiny little table populated with a new column, and they would really like it tomorrow and not have to wait 2 weeks. And I think there's ways of adjusting for this. But the more that the data engineers use the same methods and processes and fully participate in the culture with the software engineers, the easier all these things get solved.
That's a great summary. And I think that's true. I think we're seeing a convergence at everything in the universe as code, and software engineering is at the center of that. And I think it's going to be interesting 10 years from now to see how much of the roles have all changed, because I think in the last 10 to 20 years, it's night and day. I mean, you can't even recognize some of the functions anymore. So I think, 10 years from now, I think we'll look back and be like, wow, that shift, did X, Y, and Z to what was needed. And this is the new skill that's going to be required to deliver these solutions. I definitely want to thank you for being on and sharing your viewpoints. I think it's you have some great insights. And if somebody wants to reach out to you to follow up or talk about anything you've discussed on the podcast, is LinkedIn a good medium, or is there a preferred avenue they could reach out to you?
LinkedIn is fine, or they could reach me at ken@alto.com. Thank you so much. This was a lot of fun.
No, thanks for being on. Yeah, we'll include those in the show notes because you've got an amazing background, amazing experience, depth in the subject. So hopefully if anybody has a question, they'll reach you direct. Again, thank you for being on. And that's it for this week's episode. We will be back again next week. Different guests, different set of topics. As always, look forward to hearing your feedback. And if there's any other topics that you guys would like us to cover, always looking to see that. And also subscribe to the podcast. It's been growing. It's kind of exceeded our expectation of how quickly we've seen it ramp up. But if you could subscribe to it, then that helps just expand the reach, and also leave a review, good or bad. That's the only way we're going to learn it to improve the podcast. But until next week, thanks.